Okay, today we got problem 332, Reconstruct Itinerary, which I already tried to solve like twice, but I couldn't figure it out. So let's hope I can get it this time. It's the last problem of Leetcode 150 I have left, so let's get it. So basically we just got like a oriented graph, and we need to find a route which visits everything starting from some vertex. We should return the smallest one, and lexicographically, and we need to use all tickets once and only once, and there is at least one valid itinerary. So if you need to visit all edges, that screams like Eulerian path. I think it's Eulerian path or Hamiltonian. I guess Eulerian. Let's call it Eulerian. So this got length of 300, which is weird because I think you can do it in linear time. Maybe because of the sorting, but that still doesn't make sense. Well, what we need to do is go from JFK, right? And then we go, right? And whenever we get stuck, which means there is an end, right? Or there is nothing else to go, then we backtrack until we find something with unvisited, right? And then we go there. That means there is a cycle. So because it cannot be two branches that are not connected somehow, because then there would not be a path. So there could only be some sort of a cycle structure here, so we would continue from there. So essentially, actually, we run a DFS and we do some sort of top sort where this will be our first element, right? Then we go backwards, and then we okay, you have neighbors, no, okay, that's it. If you have DFS there, right? And then put this guy in, and again and again, and then reverse the answer. Here you start from JFK, you go to ATL, you go to SFO, you are done. No, you are not done actually. Because from SFO you can go here, and from here you can go here, and then you can go here. Yeah, it would work. If we remove this edge, it would still work, because let's say we would just go this lexicographically. Right, but then you realize you don't do this cycle, so you go backwards, right? Because you cannot go anywhere from here. And you go, oh, that's a cycle, so boom, boom, right? You go here, here, and then you cannot go anywhere here. So you return this, then you return this, then you return this, or what this, so this, I don't even know. Let's get it. Can be multi-edges, I guess. For maybe in tickets. Okay, and then we start in JFK. I mean, normally you check if JFK is in and ticket is not empty, but we have at least one ticket, and I guess JFK is guaranteed to be there. You don't have cycles, which is nice. Uppercase English letters, I mean, and don't say JFK has to be there technically, but they say there is one valid itinerary and you have to start with JFK, so I guess JFK is there. So we go 4x in Aj, and then we do Ajax list sorted, or we can do like Ajax sort maybe, I don't know. Let's see if this works. Oh, it's just single direction, okay. Okay, it works. So result, and then we are in like vertex, like and then we start with JFK, right? And then, I mean, do we really care about the visited though? And actually, I'm not sure how we could do like key is equal to can't really do that, so list sorted hx reverse, maybe this, so sort like that, fair enough. And then what? Good question. So we do while Aj vertex res append v. Aj v pop, not sure how it's in Python and DFS, so maybe like that. That's ridiculous. Are you kidding? Holy moly. Well, that was way easier than I thought. That's crazy. Holy. Ha! Ridiculous. Oh my days. Okay. That's crazy. Okay, let's see. So topological sort with deletions all of m, I guess. So problem asks for Eulerian path visiting all edges exactly once. I.e. an Eulerian path. Now what's up with that? for a path visiting all edges. Okay, let's say we just start from JFK and pick unused edges until we can't, e.g. Which happens either when we visit all edges or we got to the last node, to a node without an outgoing edge. In the first case, we don't have to do anything. In the second case, however, let's think about what edges are left in the graph. It can only be cycles attached to some vertices, since then the condition of at least one valid itinerary always existing would not hold. So if we instead backtrack from the last node until we get to a node with some edges left, we simply start the process from the node backtrack from the last node while removing the backtracked edges until we get to a node with some edges left. We simply start the process. We simply start the original path building from the node. The result will be the itinerary reversed. Approach: we first build the graph using an adjacency list and sort all the lists from largest to smallest, so we can pop from them in one time. I think it's like this: approach or approach. It's not definitely not like that. Okay, then we simply run a DFS and which goes over the neighbors in reverse order, i.e. from the back of the list, since we are constructing the reverse of the itinerary, so we also iterate over the neighbors in the reverse order. Finally, after we finish running DFS on all neighbors, we add the current vertex to the reversed itinerary. After the DFS finishes, we simply return the reversed, return the found itinerary OM, where M is the number of the edges since we first built the, I mean technically it's not that, but M log M sort the lists and then simply remove all M edges. I mean technically it's not that, I mean it's M plus N during A O N plus M DFS edges. Remove all each edge in O1 during A O N M DFS, which therefore takes ON plus M, where N is number of the edges. So technically we don't know what's larger, I guess, so it should be like M, it should be like this. Which I guess looks ugly. No, that's M. No, that's M plus N plus M log N. So it's just this. Okay. Which takes OM log M and then simply remove each edge in O1 during a DFS, which therefore takes O and N, where N is the number of vertices, which gives us a total time complexity of something, N plus M log M, I don't know, M plus log N, which simplifies to log M, since M grows asymptotically slower. Okay, it took longer to write up than to code, that's funny. OM, since we store the not really N plus N is since our extra memory is just the adjacency list. The itinerary does not count since that is the answer. Okay, can't post goodbye, Leetcode 150 done.